Oops, sorry. Right, so we're in 15.8 still, hopefully getting that triple integral spherical coordinate stuff finished today. And here's my first question. I just basically wrote that down a few moments ago. Finding the volume of the part of a ball, which is just basically the whole sphere, with that relationship that lies between this angle and that. In the big scheme of things, that is the simplest question you could get. I'm going to call this region E. And so what you're going to look at basically is what are the values that we're going to use? Well, there is no mention of theta. So unless it says something about it's in the first octant or whatever, theta is going to be that. The phi is really just given to me. And lastly, rho is just given to me. So our triple integral is going to be that guy. There's our general formula. So I'll do my 3-looking guy. What we're going to do next is I'll just put in some values. I try to remember what order I typically do. I do rho first. So it's going to go from 0 to 4. And then I'll do theta second. So it's going to go 0 to 2 pi. And then phi is going to go from the small guy to the big guy. So small guy is pi over 4. Big guy, pi upon 3. So this is a version of 10. Now you want a volume, you do that one. You just do one. And this fella here is always there. Would you agree this guy is variable separable? Right, so I got a sine of phi, so I'll use that guy. Pi upon 4 to pi upon 3 of the sine of phi. We'll do 0 to 2 pi of 1. And we'll do 0 to 4 of rho squared. And I think I'll just dot that. Would you agree? It's pretty much 3 separate calc 2 integrals. Nothing actually even to deal with. They're really all straightforward. Are we okay with that as our warm-up guy? Now, you know you get your test on Monday, so when you're talking about your test on Monday, you know, like this sheet of paper I've got here, you know, have one of these, maybe your version of it somewhere handy. Try to remember all these details. I could never remember whether it was rho or rho squared, or whether that was cosine or sine and whatever. So just having it there is helpful. Are we good with 10? Can I move on? Right. It's just a warm-up. Next fella. This is going to be version like 11. We're going to find the volume that lies above a cone. And the cone is described by that fella. And below, and a sphere. And the sphere is described essentially like that. Okay, so.
Is that a theta or a phi?
This is a phi. I'll double check it, make sure I'm doing it. It is a phi. Phi is pi upon 3, and rho is 16 cosine of phi. So first thing I'm going to do is trying to figure out what the heck this shape really is, because it's not really that clear what the thing looks like. So if you take this guy and you do that guy, You get that out of it, right? If you multiply both sides by rho, you get that guy. So I'm just playing about with it to can see what the heck's going on here. And now I've figured out what this guy is. This guy is x squared plus y squared plus z squared. And this guy here, I believe, is 16, is it y? It doesn't matter. Let's just set up the constraints. I thought I would be that 16y, but it's not. I'm trying to figure out what kind of sphere they're talking about. I can't find it, so I'm just not going to bother. I can get it without it anyway. So we're looking at, there's no constraints on theta, so that's good. What I know about the rho value is that it's 16 cosine, and it always starts at 0, and I'm just basically using that constraint. And then what's the phi constraint going to be? Well, it's a cone. I guess we're talking about that guy. So this piece of information generated that. This piece of information generated that. They're telling me that's a sphere, and I'm trying to figure out where the heck the sphere is. I'm just going to assume that it's a sphere because they tell me it is. And there was no constrictions on that. If they had said all of this stuff here, and in the first first octant, then I would have changed this guy accordingly, right, to 0 to pi upon 2. But since there is no mention anywhere of what theta is, I think we can be safe to assume that it's that. So you put this whole package together, and you are going to be able to find its volume, because it's going to be phi is 0 to pi upon 3. I don't know why I'm doing it in this order, but I guess that's my usual order. Equals 0 to 2 pi. And rho equals 0. Oh, I know why I'm doing it this time. Of 1, and then you fill in this stuff. Rho squared sine phi d rho d theta d phi. When they're all numbers, it really doesn't matter which order I put these things in, right? But why is this guy has to be first?
Because it has a variable of phi.
Right. Now, could I have switched places with these two guys?
Yeah.
Yes.
Yeah. And now I'm looking at it, I'm wondering myself, maybe I should have, because when I do this, aren't I going to get an answer with a whole lot of phi's in it? And it might be a good idea to take care of it at that point. But I guess I should do one of them. So where are we going to go? That's 0 to pi upon 3. This is going to be 0 to 2 pi. And this fella here is going to be 1/3 rho squared sine phi d theta d phi. And it's going to be evaluated at 0 to 16 cosine phi.
And it's also going to be rho cubed.
Yes, thank you. So it's going to be 0 to pi upon 3, because I'm tired of writing all the other variables. You plug this guy in, it's going to be 1/3 16 cosine phi cubed times the sine phi. And if you plug in 0, it gets you 0 good. So I don't need to worry about anything else. And those two guys to finish. Well, now that I see what's going on here, would you agree that everything here is in terms of phi? Right. Now, since I've bad choice of variable order, since I'm doing this with respect to theta, isn't that basically just going to stick a 2 pi at the end? Does that make sense? Or do you want me to just swatch these variables so you don't need to do that? But I'm saying, like, that's like 5. So it's just going to be 5 theta. So it's going to be 5 theta times this guy over that guy. So that's going to get me a constant. If you don't like that, you can switch the order yourself and kind of see that what I said does work. So I'm going to get, oh, goodness gracious, 16 cubed. What a ridiculous number. 4,096 over 3 times a 2 pi times a sine phi times a cosine cubed phi d phi. That is just a mess. So I'm going to pull that out. 8,192 thirds pi. And now all we're left with is that guy. Okay, Calc 2 question. How do you get the answer? How do you integrate this?
U sub
Yep. Who's the U sub?
cosine.
Right, so you do a cosine, you're going to get negative, what are you going to get? Negative u cubed du. And that guy is going to get you negative 1/4 u to the 4. So you're going to get that fella evaluated at 0. And pi, okay, I've done enough. Dot, 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 dot. Right. That question just kept on going. The thing that's bugging me is they tell me it's this is a sphere. And I don't see how that's a sphere. So I want to see if I can figure out how that is a sphere. How does that generate a sphere?
We could plot it.
Yeah, but I think if I go to Desmos, won't it just do X, Y's, and Z's? Well, I guess I could just call this. Nah, no. See, this is spherical, so it has to be spherical, or it won't make sense. It's saying the distance from the origin is a multiple of the cosine of phi. Why would that generate? Don't see it. Okay, I'm just going to have to be a believer. They tell me, they could have told me it's anything. They could have told me the cone and the banana. It wouldn't have mattered. I would still have done the same math, right? Actually telling me what it is actually distracted me more than helped. So, is what it is. Next one is another volume question, and it's version 12. This time I do recognize that guy. That's the surface of a sphere. That I recognize as a cone. It says it's above the XY plane. So if you imagine the XY plane, aren't we talking about the ground up? That will make a restriction, right? So far, so good. So let's set up what all of this kind of generates. Would you agree that this fella here generates rho equals 7? Are you happy with that? So I'm going to go that fella. Okay, what else do we know? Do you know if you solve this one? I think we did this yesterday. Doesn't that end up being phi equals pi upon 4? Can you remember the cone one that they did there? And it was the same thing, or do you want me to go through the math of why that becomes this?
Could you go through it again?
Sure. So I'm going to use that z is equal to x squared plus y squared. And I'm going to replace the x with this fella. So it's going to be rho sine phi cosine, theta squared plus rho sine phi sine theta squared. And I'm going to replace z with rho cosine phi. Right, this guy gets you rho squared sine squared phi cos squared theta, rho squared sine squared phi sine squared theta. They share a common denominator. So that's going to be rho squared sine squared phi, a cos squared theta plus a sine squared theta. But that's 1, so it becomes this guy, which if you take the positive square root becomes this guy. So we now have this relationship. If you divide both sides by rho cosine phi, you get 1 is equal to this fella. 1 is equal to the tan of phi. When is tan of phi equal 1? It's equal to 1. At least in the constraints that we've got, it has to be pi upon 4. We cool with that, guy?
Yep.
Right. So you want to get phi. It always has a restriction on one side. So we got this fella. Is there anything in this that I need to worry about in the XY plane? No, the XY plane can still use all the thetas. So won't theta be 0 to 2 pi? So this particular question then is going to be a triple integral. Rho is going to go from 0. Let's do it in the order I try to do it in every time. We'll do the rho's first. Put the thetas in the middle. And do the phi's at the end. Of 1, then you do rho squared sine phi d rho d theta d phi. And then I recognize variables separable,
Okay.
and off you go and do the rest.
Sorry, I didn't mean to unmute myself.
No, are we good?
Yeah, we're good.
We're good. Can we imagine, I know this question doesn't have it, but can we imagine that this answer, because I need an answer to work with, can we pretend that the answer is 4 pi? be a miracle if it was, but can we pretend it's 4 pi? Then this would be the volume, right? And if the density function's 1, then it would also represent the mass. So how do you get X bar, Y bar, and Z bar in this situation? Well, it'd be 1 over the mass of the volume. This fella would be the triple integral of that region that we just described, so I'm calling it E. When you stick an X in there, and then you'd have your rho squared sine phi d rho d theta d phi. So the only major difference is that that X has to be converted, this guy here, has to be converted into a rho sine phi cosine theta. You can see that it's basically just another spherical triple integral. Okay. So just to show you, if you did get a question where you had to also move on and get it. Ah, guess what? I should have just waited. Question 13 does exactly that. So in question 13, we have Z equals the square root of X plus Y squared. And we have a sphere, X squared plus Y squared plus Z squared equals, say, 4. Now we are going to find the center of mass. So basically the center of mass in this case is the density function is 1. So the volume will be the triple integral of 1 dV. This guy I just did a few moments ago. Would you agree that rho goes from 0 to 2? That theta goes from 0 to 2 pi, and phi goes from 0 to pi upon 4, because we just found out about that. And that one fella with the dV now gets replaced, because we're doing polar, by this fella. So we're going to calculate the volume of the region between when a cone meets up with the sphere. So I could imagine a big sphere with somebody getting a big sphere made out of a very soft material, and somebody gets a metal cone and just sticks the darn thing right through it. There's going to be a lot of interaction between those two surfaces. Now, if you fight your way through this entire calculation, I have an answer here, so I'm going to just pretend that I knew it. It's that guy. So how would you find X bar, Y bar, and Z bar? Well, I'm going to cheat. Why are those two guys 0? So you've got a cone and a sphere interacting, and I'm not quite sure how, but they're interacting, and so you've got a surface that's made up of both of those things. If you look at it vertically, aren't you looking at circular shapes? I don't know how they interact, but let's say they interact in the form of a donut. Can you imagine one cutting a hole through the sphere, right? At every single one of those slices, isn't the X and Y coordinate going to be the origin 0, 0? So you can see how the center of mass would be directly above the origin. Has that convinced anyone or not? Okay, if it doesn't convince you, can you spend another half hour finding X bar and getting 0, finding Y bar and getting 0, and then you can say, oh, it was 0, 0. And that's totally okay as well, right? I'm just trying to use symmetry. I'm just trying, you know, if you can figure some darn way to avoid doing something and it's the right answer, you probably should. So to get Z bar, it's 1 over the mass, the triple integral, right, of the thing, dv. That's essentially, because that's a unit.
Go back to screen share.
Say again?
We don't have your screen anymore.
Oh, what is, I don't know what I'm sharing, but everything else I'm not sure what I should be sharing. Here we go. So that's my little visualization of why I'm making these two 0, because cones and spheres look circular from above, right? If you stare down at them, they're both circles. And they're both circle centers at the origin. So that's my argument. So this fella here is going to be all of this times a z dv. Now, I'll just call that m, right? According to the solution I've got, it's that number, but whatever it really is, we'll call that m. The triple integral is the same as before. 0 to pi upon 4, 0 to 2 pi, and 0 to 2. I have a z here, but don't I just, there we go. Don't I just replace the z by r cosine of phi? Since it's polar, I also have rho squared sine phi, and then I can do the phi, the rho I should say, the theta, and the phi.
You
Now
said
this
it's
guy,
r
sorry.
cosine phi
Right.
at the beginning of it. You put rho.
Here, yeah, z is rho cosine. That's representing the z,
All
and
right.
that's representing the dv. So, what is it you think I've not done right? Put a little bracket
I
around
was
it.
thinking you initially said r cosine.
Oh, I may well have. That is very possible. I didn't mean to, if I did. That times that gets me a rho squared. I guess I've got a sine of this guy, cosine of the same guy, and we've got this.
It should be rho cubed.
Correct. I did that earlier today, didn't I? Variable separable. These two guys belong here. No, bracket should be there. The middle guy is dead easy. And the last guy is this fella. Are we happy about this splitting into 3 separate integrals? This fella is 2 pi. This fella is 1/4 r to the 4, just 4. So I'm stuck with this fella. What method would I use to integrate sine theta, cosine theta, d theta?
Yusuf?
Yeah, probably pick cosine. No, probably pick sine. That would work. Or I could
You could
recognize
also-
it. Yeah?
You could
Continue.
turn it into sine of phi over 2.
Ooh, I wonder if what you're really meaning is a half the sine of 2 phi.
Yeah.
Yes, and you could do that. And it might not look the same, but I bet you when you're finished, the number's the same. I have no idea what that is, so I'm just going to pretend it's root 2 over 2, right? Won't that get you the z bar? And you're finished. So you can use spherical coordinates to find centers of mass. The classic formula is got a z here. When it was x bar, there would be an x here. If it was y bar, there would be a y here. And the x, the y, or the z would get replaced by this. That piece here, that entire chunk there, is dv. And that's always going to be here whenever you do spherical. And this bit just depends on whether it's an x, a y, or a z. So if I really did want to do this question from scratch to find x bar, which I'm telling you 0, wouldn't the only change to this question be that that would be an x, which means that would turn into a rho sine phi cosine theta question, right? Would you agree? Now, when you do a variable separable, won't you get a theta, a cosine theta between 0 and 2 pi? What's the antiderivative of cosine theta? Antiderivative.
Sine.
All right. What happens if you find sine between 0 and 2 pi? What's the answer to that piece?
0.
And if that's 0, won't it not matter what the other two are, because won't the whole thing be 0? Have I now convinced you that x bar is 0 without doing it?
Yep.
Good. I hate magic. If visual doesn't work, imagine cosine theta being there, and that becomes 0, so the other two can be as ugly as you like. 0 times ugly answer is still 0, and so x bar would be 0. All right, what have we got time? We've got a shape that lies above z equals x squared plus y squared, and it lies below z equals 4y. And you're being asked to find, use either cylindrical or spherical. Anybody want to have a shot at this? What would this guy look like if I decided to use cylindrical? Well, wouldn't this guy be z equals r squared? And wouldn't this guy be z equals 4? And what does y look like in cylindrical?
R sine theta.
So your triple integral, if you do this particular guy, is a, well, which one of them is the biggest? I think it's this one. It'd be that guy for z's. Wouldn't the rest just be a circle? So r would go from, what would r go from? 0 to, oh, that's interesting. From 0 to 4 sine theta. And then theta would go 0 to 2 pi. And then you just do 1 r. What's the function? Oh, I didn't tell you what the function was. It's that one. So you do rz dr d theta dz, whatever order you feel like. That would do it as cylindrical. That looks pretty nice. I would probably leave it as cylindrical then. If you try to do it as spherical, I guess you could do it, but it'd be messier. So my advice to 14, I haven't really done the question totally, but I would say use cylindrical. Somebody try spherical. You can tell us next day whether it came out even better. Okay. Next couple of questions are evaluate by changing. Yep, we've got time. Evaluate by changing the triple integral from Cartesian to polar. So in this case, you get 0 to 10, 0 to the square root of 100 minus x squared, and the square root of x squared plus y squared to the square root of 200 take away x squared, take away y squared, and then they have xy, dz, dy, dx. Now, I don't really care about that, because if I change this into spherical, won't the x just get replaced by this, and the y that'll get replaced by that? Agreed? Right, so let's see what this is. It says this is z. The top limit looks like that guy. If you square both sides, then the top limit is that guy. And if you rearrange it, isn't the top guy a sphere? Radius is square root of 200. Now, the bottom guy is this fella, right? Great. And this fella, well, I know who this fella is because I've seen 3 of them today, I think. Definitely 2. What is that guy?
Phi equals pi over 4.
Right, it's a cone, and it's that guy. So I've got a sphere playing with a cone. So what's that going to look like? Well, theta can go from 0 to 2 pi. Phi can go from pi, is it going to be positive? I think so. Pi upon 4 to pi upon 2. Why do I know that? Don't. It's 0 to pi upon 4. And what do I know about rho? Well, rho basically comes from my sphere, so it's what, 0 to the square root of 200. And then I'm just going to write x and y, because x and y is going to get replaced by that ugly mess and that ugly mess. And then won't the dv be replaced by that ugly mess? So that guy gets replaced by him, the y gets replaced by him, and the x gets replaced by him. But at least it's variable separable, right? And you can get the answer. A little bit rushed, but have I given you enough information that you could figure out how to fill in the gaps? Right. Okay, last one. That's my goal. So I got a -5 to 5. I get a -25 take away y squared, and I have a 25 take away y squared, and I have a -25 take away x squared, take away y squared guy, and at the top here I have a 25 take away an x squared, take away y squared. We have a whole horrible mess in here, but I don't care what it is. And then it's basically dz, dx, and dy. If you take this guy, can you trust me that eventually you get a sphere? If you take this guy, can you trust me that you basically just get a circle? And if you take this guy, it just reinforces the fact that you've got a circle. Now, since you've got a circle on the XY plane, that means we can do the theta equals 0 to 2 pi, and we can do the phi equals 0 to pi over 2, and rho, because of this, is 0 to 5 of that ugly mess turned into using rhos, these guys here, followed by that fella. So pretty messy. I want to rewind something. It's just came to me. I gave the wrong limits of integration on this fella. That is the correct one for this fella. Do you notice how it goes negative to positive, negative to positive, negative to positive? Do you see that involves everybody? Isn't this only using the positive values for y and x? Which means if you're only using the positive values for x and y, aren't you only talking about this part of the world? So theta doesn't go from 0 to pi. Theta goes from 0 to pi upon 2. Now, since these are positive, and this is the upward motion, right, that guy there, aren't you only going to be using the top half of the shape? So that actually I got lucky. I'll rewrite this neatly. This guy, because it's only in the first quadrant. This guy is okay because it does represent only the positive part of the z's. And this guy was okay all the time. So that's the change that I made to 15. And this last one, question 16, the whole thing's being used all the time. So 0 to 2 pi, 0 to pi upon 2, and the last guy is that. This here will be a horrible mess, but it will be variable separable. So you will be able to eventually get an answer. And I don't believe it, but I'm looking at the answer here because I get the answer for free. Evidently, the answer is going to be 0. Well, all that tells me is that this triple integral doesn't represent a volume. Not all triple integrals do. Maybe it's representing the total energy in something, and 0 means the whole thing's balanced. How would that